One, two, three, let's go!
Hello, good day everyone. Welcome to Mathematics in the Modern World. So have fun as I am going to tackle about the language of relations and functions. So the following are the learning objectives for today's video tutorial regarding the language of relations and functions. First, we would illustrate a relation and a function, and then we would verify if a given relation is a function. And then we would relate function to real-life situations. A relation R from a non-empty set A to a non-empty set B is a subset of the Cartesian product set A cross B. The subset is derived by describing a relationship between the first element and the second element of the ordered pairs in A cross B. So the set of all first elements in a relation R is called the domain of the relation R, and the set of all the second elements is called range or codomain. So keep in mind that relation is any set of ordered pairs. The set of all first elements of the ordered pairs where the arrows come from are called the domain of the relation. And the set of all second elements where the arrows end are called the codomain or the range. A relation may be classified as one-to-one, many-to-one, or one-to-many. So it is one-to-one relation if every element in the domain is mapped to a unique element in the range. So here is the example of one-to-one relation. 1, 2, 3, and 4 is the element in the domain, and 3, 4, 5, and 6 is the element in the range. So every element in the domain, example like in this number 1, is mapped into the range, which is the number 3. 2 mapped to 4, 3 mapped to 5, and 4 mapped to 6. So it is many-to-one if 2 or more elements in the domain are mapped to only one element in the range. So here is the example of many-to-one. There are 2 elements, which is the positive 2 and negative 2, that are mapped to only one element in the range, which is the positive 4. It is one-to-many if each element in the domain is mapped to any 2 or more elements in the range. So here is the example of one-to-many. There is only one element in the domain, which is the positive 9, that is mapped to 2 elements in the range, which is the positive 3 and negative 3. A combination of a many-to-one relation and a one-to-many relation is called a many-to-many relation. So here is the example of many-to-many relation. So there are 2 elements in the domain that are mapped to only one element in the range. And also there is one element in the domain that are mapped to 2 elements in the range. So that is the example of many-to-many relation. So here is the example number 1. The set R is equal to the set of 1 and 2, negative 2 and 3, 1/2 and 3 is a relation. Identify the domain and range of the set R and use roster method. So for the solution, the domain of R is equal to the set of 1 and 2 and 1/2. And the codomain of R is 2 and 3. So a relation may be represented either by the roster form or by the set builder form, or by an arrow diagram, which is a visual representation of a relation. Example 2. Let y is equal to the set of 0, 1, 2, 3 and z is equal to the set of 0, 2, 4, 6. And define a relation R from y to z as follows. Given any ordered pair of x, y is an element of y cross z. That ordered pair x, y should be an element of R means that the relation is x plus y over 2 is an integer. The first question is state explicitly which ordered pair are in y cross z and which are in R. Letter B, is 1 related to 0? Is 3 related to 0? Is 2 related to 4? And letter C, what are the domain and codomain of R? Solution. In order for us to explicitly state which ordered pairs are in y cross z, the crossing we just start crossing from y to z, the same in the figure shown. We have here x cross z. Take note that you have to put the ordered pair in a set. Y cross z is equal to the set of 0, 0, 0, 2, 0, 4, 0, 6, 1, 0, 1, 2, 1, 4, 1, 6, 2, 0, 2, 2, 2, 4, 2, 6, 3, 0, 3, 2, 3, 4, and 3, 6. These are the ordered pair which ordered pair are in y cross z. Next, which are in R. Stated that ordered pair xy should be an element of R means that the relation is x plus y over 2 is an integer. We have here 0, 0 is an element of R because 0 plus 0 over 2 is equal to 0 and 0 is an integer. 0, 2 is an element of R because 0 plus 2 over 2 is equal to 1 and 1 is an integer. 0, 4 is an element of R because 0 plus 4 over 2 is equal to 2 and 2 is an integer. 0, 6 is an element of R because 0 plus 6 over 2 is equal to 3 and 3 is an integer. 1, 0 is not an element of R because 1 plus 0 over 2 is equal to 1 half and 1 half is not an integer. 1, 2 is not an element of R because 1 plus 2 over 2 is equal to 3 over 2 and 3 over 2 is not an integer. 1, 4 is not an element of R because 1 plus 4 over 2 is equal to 5 over 2 and 5 over 2 is not an integer. 1, 6 is not an element of R because 1 plus 6 over 2 is equal to 7 over 2 and 7 over 2 is not an integer. 2, 0 is an element of R because 2 plus 0 over 2 is equal to 1 and 1 is an integer. 2, 2 is an element of R because 2 plus 2 over 2 is equal to 2 and 2 is an integer. 2, 4 is an element of R because 2 plus 4 over 2 is equal to 3 and 3 is an integer. 2, 6 is an element of R because 2 plus 6 over 2 is equal to 4 and 4 is an integer. 3, 0 is not an element of R because 3 plus 0 over 2 is equal to 3 over 2 and 3 over 2 is not an integer. Next, 3, 2 is not an element of R because 3 plus 2 over 2 is equal to 5 over 2 and 5 over 2 is not an integer. 3, 4 is not an element of R because 3 plus 4 over 2 is equal to 7 over 2 and 7 over 2 is not an integer. 3, 6 is not an element of R because 3 plus 6 over 2
is equal to 9 over 2, and 9 over 2 is not an integer. Only the following R is equal to the set of 0, 0, 0, 2, 0, 4, 0, 6, 2, 0, 2, 2, 2, 4, and 2, 6 are the elements which are in R. The ordered pair of x, y, z, only the relation are the following: 0, 0, 0, 2, 0, 4, 0, 6, 2, 0, 2, 2, 2, 4, 2, 6. And letter B. Is 1 related to 0? No. Is 3 related to 0? No. And lastly, 2 is related to 4? Yes, because 2, 4 is an integer. And for letter C, R is equal to the set of 0, 0, 0, 2, 0, 4, 0, 6, 2, 0, 2, 2, 2, 4, and 2, 6. Our domain is the set of 0, 2, and our codomain is the set of 0, 2, 4, 6. Example 3. Let A is equal to the set of 2, 3, 4, and B is equal to the set of 2, 4, 6, and let R be the divised relation from A to B. For all ordered pair of x, y is an element of A cross B, and x related y if and only if x divides y. Draw an IO diagram for R. Solution. We have here A is equal to the set of 2, 3, 4, and B is equal to the set of 2, 4, 6. First, we have 2A cross B, which is equal to the set of 2, 2, 2, 4, 2, 6, 3, 2, 3, 4, 3, 6, 4, 2, 4, 4, and 4, 6. Then, let's determine R, which part is R. We need to locate the ordered pair which x divides y. 2, 2 is an element of R because 2 divides 2. 2, 4 is an element of R because 2 divides 4. 2, 6 is an element of R because 2 divides 6. 3, 2 is not an element of R because 3 does not divide 2. 3, 4 is not an element of R because 3 does not divide 4. 3, 6 is an element of R because 3 divides 6. 4, 2 is not an element of R because 4 does not divide 2. 4, 4 is an element of R because 4 divides 2. 4, 6 is not an element of R because 4 does not divide 6. These are the relation of x divides y. R is equal to the set of 2, 2, 2, 4, 2, 6, 3, 6, and 4, 4. We have here a diagram. We have here the set of A and B. In A, we have 2, 3, 4, and B, we have 2, 4, 6. The relation here is x divides y.
Representation of relation. So aside from mapping, a relation may be represented in 4 other ways. So it can be in a table, ordered pairs, graph, and equation. Relationship between two variables can also be presented by a table. Given the following as the example of the situation which Mr. Carlos is a dealer of poultry eggs. The table shows the cost for each number of trays. So the number of trays of eggs, which is number 1 up to 5, and the cost in pesos, presented horizontally and vertically. So there are 5 trays of eggs and each tray costs 200 pesos. Relations expressed in ordered pairs. So based on the example above, the following ordered pairs were derived from the relationship between the number of trays, x, and the total cost, y. Then the ordered pairs are 1, 210, 2 and 420, 3 and 630, 4 and 840, 5 and 1050, and in general as x and y. Relations expressed as a rule of equation. So first, a relation may also be presented through an equation into variables or certain rule expressed in equation. Now let us model the relationship of total cost and the number of trays of eggs through the equation. So its total cost is the cost per tray of eggs and the number of trays. Then y is equal to 210, which is the x, is the rule expressed through equation into variables. Using the existing rule, y is equal to 210, we can determine the total cost of the numbers of trays of eggs sold. Relation described graphically. So here is the example of the relation described graphically. So the x-axis represents the number of trays of eggs, while the y-axis is the total cost of tray in pesos. So try to answer and try this to find which of the sets below correspond to given R. It could be letter A, 2 and 4, B, 3 and 8, C, 6 and 8, or D, 8 and 7. Relations that are functions. So function is a special type of relation where no element in the domain is mapped or paired to more than one element in the range. By looking at the definition of a function, one-to-one relation and many-to-one are functions, and one-to-many and many-to-many relations are just mere relation.
Determine which of the following sets of ordered pairs is a function. A is equal to the set of 3, 5, 2, 7, 4, 6, negative 3, and 5. And B is equal to the set of 0, 1, negative 1, 2, 0, 3, negative 2, 4, negative 1, and 5. Solution. Set A is a function since there are no distinct ordered pairs having the same first elements or domain. Set B is not a function since ordered pairs 0, 1 and 0, 3 have the same first elements. Note, the set of ordered pairs represents a function if no two or more distinct ordered pairs have the same first element or domain. Example 2. Let A is equal to the set of 4, 6, 8 and B is equal to the set of 3, 5, 7. Which of the relations R and S defined below are functions from A to B? A. R is equal to the set of 4, 7, 6, 3, 6, 5, and 8, 7. B. For all ordered pair of X, Y is an element of A cross B. The ordered pair of X, Y is an element of S means that the Y is equal to the X plus 1. Solution. We are going to graph. We have here A and B. Our A have 4, 6, 8, and our B have 3, 5, 7. 4 is paired by 7. 8 is paired by 7. 6 is paired by 5. And 6 is paired by 3. Letter A is not a function because since the ordered pairs 6, 3 and 6, 5 have the same first elements or domain. For letter B, stated that S means the relation is y is equal to x plus 1. We have here 4, 3 is not an element of R because 3 is equal to 4 plus 1 and 4 plus 1 is 5. So 3 is not equal to 5. 4, 5 is an element of R because 5 is equal to 4 plus 1 and 4 plus 1 is equal to 5. So 5 is equal to 5. 4, 7 is not an element of R because 7 is equal to 4 plus 1 and 4 plus 1 is equal to 5. So 7 is not equal to 5. Next, 6, 3 is not an element of R because 3 is equal to 6 plus 1 and 6 plus 1 is equal to 7. So 3 is not equal to 7. 6, 5 is not an element of R because 5 is equal to 6 plus 1 and 6 plus 1 is equal to 7. So 5 is not equal to 7. Next, 6, 7 is an element of R because 7 is equal to 6 plus 1 and 6 plus 1 is equal to 7. So 7 is equal to 7. 8, 3 is not an element of R because 3 is equal to 8 plus 1 and 8 plus 1 is equal to 9. So 3 is not equal to 9. Next, 8, 5 is not an element of R because 5 is equal to 8 plus 1 and 8 plus 1 is equal to 9. So 5 is not equal to 9. 8, 7 is not an element of R because 7 is equal to 8 plus 1 and 8 plus 1 is equal to 9. So 7 is not equal to 9. Here is our figure of our two sets. We have set A consists of 4, 6, 8 and we have set B consists of 3, 5, 7. The 4 is paired by 5 and the 6 is paired by 7. Letter B is not a function because it does not satisfy from the first condition. Example 3. Let x is equal to CAT and y is equal to a set of 2, 4, 6, 8. Which of the relations A and B defined below are function from x to y? For letter A is equal C2, A4, D6. For letter B, for all ordered pair of xy is an element of x cross y. That ordered pair xy should be an element of B, means that A is a vowel and B is even. Solution. We have here the set of xy for letter A. T is paired with 6, A is paired with 4, and C is paired with 2. Letter A is a function because letter A satisfies the property of a function. For letter B, we have the set x and y. It means that A is a vowel and B is even. A is paired with 6, A is paired with 8, A is paired with 4, A is paired with 2. Letter B is not a function because letter B does not satisfy the property of a function.
Answer on this tries and then indicate whether any of the relations U and V are functions and then explain. So keep in mind that mathematics is not about numbers, equations, computations, or algorithms. It is about understanding.